Dive. You know, it feels like everywhere you turn, there's this constant buzz about AI. It's going to change everything, right? Especially in tech.
Oh, absolutely. The hype is huge.
And the promise is always, faster, better, more efficient. Particularly for software developers, the expectation has just been sky high.
It really has.
So today, we're really diving into that promise. We've been looking at some really fascinating stuff, actually. There's a great article on LinkedIn from an expert at DSS Consulting.
Right, I saw that one. It unpacked a really key study.
Exactly. And it's not just theory. This is like actual data from people coding day to day.
Yeah, and that's what we want to get into. The core question is, how is this early 2025 AI really affecting experienced developers? Not in a lab, but like in their actual jobs.
Mm-hmm.
And, well, let's just say the findings might not be what you expect. They certainly challenge some common ideas.
Challenge is definitely the word. So our mission here is pretty clear. Let's unpack this data, figure out why the results are so, surprising, and what it all means for you, whether you're a dev, a team lead, or honestly just curious about where AI is really making an impact.
Let's do it.
Okay, so let's just cut straight to the chase. The headline finding that really made us stop and look again.
Yeah.
Our sources, including that DSS piece unpacking the METR study, point to something really almost shockingly counterintuitive.
Mm-hmm.
When these experienced open source developers, the kind you'd think would benefit most, use these top-tier AI tools,
Mm-hmm.
they actually took longer.
Longer. Yeah.
19% longer on average to finish their tasks compared to when they didn't use AI. Slower.
It's kind of wild, isn't it? And what's really fascinating, maybe even a bit unsettling, is the gap between that reality and what the developers thought was happening.
Okay, tell me about that.
So they went into it expecting that AI would make them like 24% faster. Pretty optimistic.
Standout expectation, right.
Totally. But here's the kicker. Even after using the tools, even when the data showed they were 19% slower, they still believed the AI had sped them up.
No way. By how much?
They perceived a 20% speed increase. So you've got objective reality over here saying 19% slower, and subjective feeling over there saying 20% faster.
Wow.
That's
a massive disconnect.
It's huge. And it really makes you question how we perceive the impact of these tools, especially with all the hype,
Absolutely. It flies in the face of, pretty much everything we hear, both from developers themselves and all the expert forecasts. It really begs the question, why? Why did this happen?
Exactly.
So maybe we should quickly look at the study itself. Like, who exactly were they studying?
Good idea. So this METR study, they recruited 16 developers, but these weren't like junior devs or anything.
Right. You said experienced.
Very experienced contributors to really massive open source projects. I think average over 22,000 stars on GitHub. Millions of lines of code.
Okay, so these are serious, complex projects.
The big leagues, yeah. And these folks had been working on them for years. They knew their stuff. This wasn't about learning a new code base or tackling simple tasks.
Got it. And the method, how did they measure this?
It was really rigorous. They used a randomized controlled trial, an RCT, basically the gold standard for this kind of research.
Okay.
So the developers gave a list of their actual current tasks. Bug fixes, features, refactoring, stuff they were going to do anyway.
Real work.
Exactly. Then each task was randomly assigned. Either you could use AI tools for this one, or you couldn't. They recorded their screens, tracked their time, so you get a really direct comparison.
With and without AI on comparable tasks by the same experienced people.
Precisely. Super clean comparison.
And the AI they used, was it like basic stuff or?
No, it was cutting edge for the time. This was early 2025. Primarily Cursor Pro, running models like Claude 3.5, even 3.7 Sonnet. These were frontier models then.
So top of the line AI assistants.
Definitely. They gave the AI every chance to shine.
And what about METR, the organization doing the study? Any particular angle?
That's important too. They're a nonprofit, funded by donations.
Yeah.
Their main interest isn't really selling AI or proving it works or doesn't work.
Okay.
They're more focused on understanding how close AI is to like accelerating AI research itself, which has potential risks they want to understand.
Okay. So they weren't necessarily rooting for a specific outcome.
Exactly. No horse in the race, so to speak. Just trying to get good data, understand the real impact. That lack of bias really adds weight to these findings, I think.
It does. So given this totally unexpected result, expert devs slowing down with top AI, the massive question is just why? What was going on?
Right. And it wasn't just one thing. The sources point to a few key factors that sort of piled up.
Okay, let's break those down.
Well, first off, and this seems really crucial, was just high code-based familiarity. These developers knew these massive code bases really well.
Like inside and out.
Exactly. They knew the architecture, the weird quirks, the history, the conventions, everything. So the AI just didn't have many easy wins or shortcuts to offer them. They already knew the best way or a good way to do things.
Kind of like offering GPS to someone driving their daily commute they've done for 10 years.
Perfect analogy. Yeah.
Yeah.
Second, the size and complexity of these code bases was a real hurdle for the AI. Even these advanced 2025 LLMs, they still kind of struggle to ingest and really reason over millions of lines of code effectively. Context gets lost. Important nuances get missed. The AI just couldn't hold the whole picture in its head the way the human developer could.
Right, the mental model is just too vast.
Totally. Then third, there's this idea of tacit knowledge gaps.
Tacit knowledge, like the unwritten rules.
Exactly. All the unspoken stuff. Why we name variables this way on this team, or the specific design patterns they prefer, or just the subtle expectations about code style or structure that aren't written down anywhere. AI is terrible at picking that up.
Yeah, how could it? It wasn't part of the team meetings.
Precisely. Fourth was prompting friction. Just the act of using the AI added overhead.
You mean typing in the questions, waiting?
Yeah, figuring out the right prompt, explaining the context, waiting for the AI to generate something, then reviewing the output.
Yeah.
It all takes time and mental energy. It's an extra step.
And if the output isn't great, that time is wasted.
Which leads perfectly to the last point. A low acceptance rate. Less than 44% of the code the AI suggested was actually used without needing significant changes.
Wow, less than half.
Yeah. So if you're spending time prompting, waiting, reviewing, and then still having to heavily edit or just throw away the suggestion more often than not, well, you can see how that adds up to being slower overall.
Okay, that paints a much clearer picture. Familiarity, complexity, tacit knowledge, friction, and low acceptance. It makes sense in that specific context.
Right. Highly experienced devs, complex, familiar code.
But here's where it gets really interesting, isn't it? Because how do we square this result with everything else we hear? You know, the amazing benchmark scores where AI solves complex problems, the endless stories of people saying AI is a game changer for them.
That's the million-dollar question, right? The elephant in the room. We seem to have conflicting signals.
So how do we make sense of it?
Well, if we zoom out a bit, it looks less like a flat contradiction and more like we're measuring different things with different tools, each with its own blind spots.
Okay.
So you've got this RCT, our main source today. Super rigorous real-world tasks, experienced devs, specific setting, and it shows. AI slowed these people down on these tasks. Clear result.
Right, one type of evidence.
And they have the benchmarks. Things like CBDB bench, R bench. These often use AI as like a fully autonomous agent, tackling really hard, well-defined problems, often scored algorithmically. They show AI can do impressive things sometimes hard for humans.
Different setup, different goal.
Exactly. And then you have the third type, anecdotes and adoption. Loads of people saying, hey, this AI tool really helps me. Often for bigger tasks, maybe different kinds of tasks, across all sorts of companies and projects. And they feel it's useful.
Okay, so 3 different lenses. The controlled experiment, the capability benchmark, the real-world perception.
You got it. And the sources suggest a few ways to reconcile them. Hypothesis 1. Maybe our RCT is flawed somehow, or this specific setting is just weird, and it underestimates what AI can really do elsewhere.
Possible, I guess.
Hypothesis 2. Maybe the benchmarks and anecdotes overestimate things. Perhaps benchmarks focus on tasks AI is good at, and as we saw, self-reports can be way off, so maybe the RCT is closer to the messy truth.
Also possible.
But the third hypothesis, which feels maybe the most likely, is that they're all kind of right, just for different slices of reality.
Complementary evidence?
Exactly. They're measuring different parts of the overall picture.
Yep.
So this RCT result, maybe it's less relevant if you're using AI in a way where it can try thousands of solutions, which the devs didn't do. Or maybe there are long-term learning effects, like after hundreds of hours of use, these devs would get faster, but the study didn't run that long.
Ah, okay. The context of use matters.
Hugely. And conversely, maybe the benchmarks overstate things, because it used perfectly defined problems, not the messy ones developers face daily. And we already know subjective reports of speed aren't reliable.
Right, the 19% slower versus 20% faster belief.
Can't forget that. So the big takeaway is no single measurement tells the whole story. We need all these different ways of looking at it, RCTs, benchmarks, user studies, to get a truly nuanced understanding. It's complex.
That makes a lot of sense. It's not just AI good or AI bad. So bringing it back to the listener, what does this all mean for you? If you're leading a team or you're a developer yourself, what are the practical takeaways?
Okay, several key things stand out. First, and maybe foremost, Context is king. This study screams that AI isn't a magic wand. It might not boost productivity everywhere, especially for your senior experts working on code they know intimately. Don't expect a universal speed up just by giving everyone a license.
Right. So number two.
Number two, targeting is crucial. Think carefully about where AI might actually help most. Maybe it's better for greenfield projects starting from scratch, or maybe less mature code bases where that deep familiarity isn't there yet.
Or maybe onboarding new people.
Exactly. Helping new engineers get up to speed on a complex project could be a huge win, potentially much more valuable than trying to speed up your seasoned veterans on their home turf.
Makes sense. What else?
Third, don't just trust the vibes. Seriously, that perception gap is a massive warning sign. People felt faster even when they were slower.
So you need actual data.
You absolutely need objective measurement. Track task completion times, code quality, something tangible. Don't rely solely on, do you feel more productive? Because the answer might not match reality. Measure, validate, don't just assume.
Okay, crucial point. Number four.
Fourth, your adoption strategy needs real depth. It's not just about buying the tool. You have to think about how it fits into workflows. Does it interrupt flow? Does it handle your project's specific complexity? Does it clash with that unspoken, tacit knowledge your team relies on? It's more involved than just handing out logins.
Right. It's integration, not just installation.
Well put. And finally, number five, AI productivity benefits are not plug and play. You can't just switch it on and expect results. It likely requires fine-tuning, ongoing monitoring, maybe custom prompts or training, and a really clear-eyed view of when it helps and when, like in this study, it might actually hinder. It's an ongoing optimization process.
Okay, those are really solid takeaways. And just to be super clear, it's probably worth saying what this study doesn't claim, right? To avoid people overgeneralizing.
Excellent point, yes. First, it does not say AI doesn't speed up most developers. It focused on a specific group. Highly experienced devs on familiar, complex, open-source projects.
Yes.
That'd be very different for others.
Got it. What else?
It does not claim AI doesn't speed people up in other fields. This was software development. Maybe it's fantastic for writing marketing copy or analyzing spreadsheets. Different domain.
Yeah.
Also, crucially, it does not claim that future AI won't speed up even these developers. AI is moving incredibly fast. What was true in early 2025 might be different by 2026.
Good point. The tech evolves.
And finally, it doesn't claim there aren't better ways to use even current AI to get speedups in this setting. Maybe with different prompting techniques or fine-tuning the model specifically for that code base or integrating it differently into the workflow. Maybe you could get gains. The study just looked at how these devs used it naturally.
Right. So it's a snapshot, not a final verdict on AI for all developers forever.
Exactly. A very important, very surprising snapshot, but a snapshot nonetheless.
So wrapping this up, this deep dive really throws that central tension into sharp relief, doesn't it? Between the incredible promise and potential of AI that we hear about constantly.
The hype.
And the actual nuanced, sometimes really surprising reality when these tools hit the ground in complex, human-driven work like software development.
Absolutely. And studies like Entiers, the ones DSS Consulting highlighted, they're so valuable because they inject that dose of realism. They push us to look beyond the hype and anecdotes and ground our strategies in, well, actual evidence. It encourages a more measured, strategic approach.
Which leads to a final thought, maybe something for you, the listener, to mull over. In this era where tech is advancing so blindingly fast, how do we strike the right balance? How do we embrace the genuine excitement and potential of tools like AI, while also doing the hard work of understanding the messy reality of how humans and machines actually work together, and making sure we're even measuring the things that truly matter?
That's a big question, isn't it?
It really is. Something to think about. Thanks for joining us on the Deep Dive.